corner, that little computer icon. You hit that, and then here's your grid connection. So you punch in the IP address, the port, which I left a default of 9,000, and then your credentials, and then you hit OK. And it connects you. Okay, so the first tree is your user tree. Your user and groups tree, and then underneath that is your users, groups, and permissions. Now you can see I have 5 users set up, the admin, the executor, the user, and then 2 special ones that I used for application testing, because I wanted my application to be able to destroy threads after they were finished. So I gave my user, or that night user, a little bit different authority than a normal user would have, which is usually what somebody would use when they're writing an application. So if you double click on one of them users, this is what you get. You get the properties, and you can change your password from in here, and you can also see what they're members of, what group they're a member of. Like I said, everything is role-based. Okay, so then you jump down into groups, and you can see the different groups, administrators, executors, users. You can create new groups if you would like. Once you double click on that, the administrator one automatically won't show you what other administrators in here, but if you went into users or executors, it'll show you what other members are associated with that role or with that group. And then the next tab is permissions. Like you can see, the admin can execute threads, manage its own app, manage all the apps, and manage users. And then here's your permission. You can none and then those ones, and then when you double click on them, it doesn't really tell you anything. So to configure the executor is really easy. You just install the executor, keep the default settings. You just give it the credentials that are set up by the whatever the administrator of that grid. So basically just your IP address. If you leave everything default, all they'll have to do is enter the IP address of the manager system and hit connect, and you'll be connected. So here's what the executor looks like. Like you see up in manager node, the host IP and the port. The port's by default. There's the IP address of our management computer. And then the credentials are the default executor. When you're connected, it gives you the ID, so you know what ID your node is. So if you look at the statistics for your application or whatever, or there's an error log on your manager, and something happens with the communication, a thread fails, something like that, you associate it with this ID. It doesn't use your host name or anything like that. And then you can also dedicate the node, so it will only be used with one grid. If you don't dedicate it, other grids can connect to that node. And then down at the bottom, there's some log messages that you see. You see the first couple, I couldn't connect to the manager because the manager computer was shut off. So the next tab is manage execution. These are blanked out because I'm connected, but when you're not connected, you can tell it to go ahead and start application executing, and then, or stop executing. And then in your options, here's where you set your heartbeat interval. Oops, let me go back. Here's where you set your heartbeat interval. Retry on disconnection. So if your computer restarts or the manager restarts, it'll try every 30 seconds for however many times you specify. And then right there is that button to enforce the secure sandbox execution. Like I said, you can turn that off, but I wouldn't suggest it. It says to allow with legacy applications, but I've never even found an application that's legacy called gjobs. So, okay, like I said, the Alchemy console is used to manage the actual grid. It allows you to create and deactivate, activate nodes, users, groups, applications, and threads, and you can view the live statistics of your current grid. So any applications that are running, how many threads are running, how many executors you have, the processor power that is available to you, the current power that is being utilized, the current power that is being available, because there's a difference between the amount of processing power you have available and the amount of power you have available at that time. So even though we may have 14 gigahertz of processing power available, if I'm using my PC, obviously that percentage is unavailable, and it'll show you that, so it'll only be whatever, 74%, 98%, depending on whatever the ratio of that computer's processing power has to the total. So here's what it looks like in the console with the executors. This is all the executors that we used to have. We have less than that now. But at the time when I did all these screenshots, we only had one executor, which was the machine I was using to do the PowerPoint. But you can see the ones that are grayed out are inactive. They're currently not on or not connected. And then the orange ones are the ones that are active. And then if you click into one of the nodes, it'll tell you its ID, what port it's connected on. That function doesn't work. There's a bug in that part of the console. And like I said, there's a few of these things in the console that are buggy that they need to fix. The username that's associated with that grid, or with that node, and since all of my nodes use executor, it gives me executor as the username. And the last ping time, so how long ago it checked to see if it was connected, because the manager will also check back and see if things are there. And then it'll tell you if it's connected, if it's dedicated, and then if you go into the advanced tab, it shows you the architecture, so you can see what architecture that system is running on, the operating system, the max CPU, the max storage, because you can also do shared file storage between the nodes. I didn't play with that at all, so I can't give you any information on it, but it's in the documentation. And then the number of CPUs that computer has. So if I had 2, it would say 2, or 4, it would say 4, obviously. And then here's the performance of that individual node. And it shows you this little graph, and it tells you how much was available 40 minutes ago, 20 minutes ago, and current. And then here's applications. So under the applications tree, you see all these applications, and then over in the right panel, those are the threads associated with those applications. Okay. Now, an application, you need to understand, is not the actual program that is running on or for the grid. Okay. An application is created within your program that allows it to utilize the grid. You can have a program that can create multiple applications, because an application is limited by the amount of threads that it can process. So if you're running a massive job, like one of the demo programs is the Pi generator, and it does every 10 decimal places is an individual thread, and then every 10 it creates a new application to process the next 10. So it makes it so it doesn't bog down the actual grid by having this one massive application. And the other problem is when you are queuing your threads up in your application, all that information has to be sent to the manager to be queued up before it can be processed. So if you have one application, one grid application that is processing 500 threads, it has to queue all 500 of those threads up before they will start running. Okay, the entire application has to be queued before it will start processing. But if you do it in 10 increments, even though you're reading 500 lines, every 10 lines it's going to go ahead and kick off those 10 lines, because that application is finished. So you can give, like all these say no name, you can give each individual grid application a name to be able to keep track of it a little bit more. I didn't mess with that because I didn't see the point, but you can do that. You can also give it more information. So if you click on the application, you can get the properties of the application, the ID of the actual grid application, who created it. So that's the application, my program that actually created that grid application. That's what that is. When it was created, when it was completed, what state it's in. If it's currently running, it'll say running. And then the number of threads that it had on that application. So I was processing 10 threads, so it says 10. And then if you go into the thread properties, you see similar information, the application that it was associated with, the executor that it was associated with, when it was created, completed, what state it's in, and the priority. Now, priority can come into play when you're doing MPI, because you know that you need this thread to complete before this other thread completes. So you elevate that thread's priority in the queue, so when the executor comes and gets it, it grabs that one first, as opposed to first in, first out, or first in, first out. And here's the real-time statistics that you can see up in the left-hand corner. It shows you the number of executors, number of applications that are running, the number of threads that are running, the max power that's available, the total power usage for whatever recorded amount of time is in your database, the current power available, and that's what I was talking about, how that's different than the max power available. I only was able to get 5% of what I was using because I was using my computer. And then the current power usage, which is what is being used at that exact time. Okay, so programming for Alchemy. The most important thing to understand is how to parallelize code. it does you absolutely no good to use a distributed programming method if you do not know how to parallelize your code in. And like I said, that means no data dependency. The first little chunk is parallelizable. Okay, A equals 1, B equals 2, A plus B equals C. Okay, we don't care anything else because we know what A and B is, and we know our output is C. So you would probably return C every time that thread is completed. Okay. Now the second one is not parallel. A equals B, or A equals 1, B equals 2. If C is greater than B, A plus B equals C. We don't know what C is. Okay. If C was in there, then you would be able to parallelize it. But because C is not in that block, you're dependent on knowing what C is in order to complete that chunk. Now you can do that with MPI, but it becomes more complicated. But even with that, you still have to be able to parallelize everything. So it's procedurally, it doesn't get out of order, and then you start getting this big old mess of crap. Okay, just because it's parallel doesn't mean it has to be small. Just because you're doing a repetitive task, you don't have to have this all-encompassing algorithm that's one line of code that it's running every time. I mean, if you do, that's great because it's going to run fast as shit. But if it's not important at how long it takes or how much power is used per thread, then it doesn't matter what size you are using. Okay, it's also essential to understand threading and multi-threading within an application. It's different. If you're not used to multi-threading in your application, it is really different than doing just a normal, wham bam straight through application or an object or a event-driven application because you're still running on one thread. Okay, but you can set priority and run multiple processes at the same time without them interfering with other processes, and that's why you use multiple threads. Like in a normal environment, in a Windows environment, for instance, if you're writing an application and you're doing something on your GUI, okay? Your GUI, that is your thread, okay? So anything you do on your GUI, it's not going to allow the next process to go forward. Or if you're running something in the background, like you're trying to make a SQL Server connection or something like that, your GUI is going to get locked out because it's running on the same thread. And that's where multi-threading comes into play. You can send that SQL connection off to the back in a different thread, give it lower priority, give your GUI priority. That way if somebody tries to use your GUI, that thread is going to get precedence over the thread that you sent back. Okay, and then it throws another little kink in it with the grid application and the grid thread, and that's what I was talking about, where your actual program can create multiple applications, which can create multiple threads. In Alchemy, they use the terminology G application and G thread, which designates it as a grid application or a grid thread. So here's an actual thread in one of the sample applications, okay? That is the actual thread. If these things are okay, then go ahead and process the result. A times B times A. Okay, so that's your thread. Now right here, this little for loop, that actually creates your thread. So you're creating a multiplier thread, so that's your thread object, and then you're giving it the name thread, and you're telling it it's a new multiplier thread, which back here, you can see the next public function up there. That's the thread prototype. So you're passing it 2 parameters. Okay, so every time it's running through, since it's a for loop and it's passing it it's passing it different integers every time. And then it's queuing it up in this GA, which GA is the G application up at the top. And then you're queuing those threads up. And then once that is done queuing, you subscribe to the events, so the thread finish, the thread fail, and the application finish. So your application knows when something's done or when it failed or when your application is actually totally done. And then you start it, which is that actual thread. And then it does its processing, and then it tells your program when it's done. Okay, now this is another application. This is an actual thread as well. I mean, it's much larger than that other one, but it's still parallel. All this stuff doesn't depend on anything else. What this is doing is it's taking an input of a string, encoding it out into MD5, an MD5 hash, then it's connecting to a SQL server, passing that information along with the plain text string, and then loading up a rainbow table. And then here's the actual application. Now, The for loop was real small, but right here is a while loop.